For this video, we are going to write the equation of a normal line in the form ax plus by plus c using vectors. I have here vectors for the points P and Q. Now, don't worry about the illustration already presented here because actually, we had a video pertaining on the equation of the line, not the normal line, of the same form using vectors. At that time, we're able to actually use the normal vector. This is direction vector of this line, okay? And then we identify here the normal vector, okay? The direction vector of the normal line. This is for the normal line, okay? And we use this to identify the result of 3x plus 4y, this is minus 11 equal to 0, which is the equation of this line, but not the normal line, okay? Now, to determine the equation of the normal line, we will be using this to determine the equation of a normal line. So basically, you can look into this perspective. Again, you may try to revisit the video pertaining on this because we were able to identify the equation of a line passing through these points, not using a two-point form, but using vectors, starting with the direction vector of the line containing the points P and Q, then getting the normal vector. This is the normal vector, by the way, not the normal line. Normal vector of the normal line, and then later on, this pertains to the equation of the line. But for the equation of the normal line, we'll be using this instead. Okay? So we don't need to identify the equation of the normal line, the normal vector to determine the equation of a normal line in the form ax plus by plus c. So hopefully this is clear. This is different because we have a video using points P and Q with the same coordinates as well. But that is for the equation of the line. This time, equation of the normal line. So simply take the V. So this is our V here. So V, this is the direction vector of that line. So you will actually get the result of equivalent to -4 and 3. Okay, this is the normal vector. So again, in the previous video, we used this to determine your A and B coefficients, and of course for your C, this time this is now our A and this is where our B coefficients automatically. We don't need to identify the normal vector if you're just targeting the normal equation of a normal line. Okay, so with this now, this our A is -4 and B is 3. By the way, before you can reach this video, try to review those videos previously provided because it talks about the normal vector, talks about equation of a normal line, equation of a line in the form L is equal to P. Then this is for the normal, this is the line, and then for our normal line is actually this form. Okay, so we were able to discuss all of this as well. So don't skip those videos before this one. Okay, so this is our A and B, and since we're targeting A, x plus by plus c equal to 0, we can now, the next step, or this is now our first step, the next step now is identifying the value of your C. Okay, because this time we need to complete this to get the general form or the form of ax plus by plus c equal to 0. But which x and y coefficients? Because we don't have a point yet on the normal line we're trying to look at. Now, our normal line is a perpendicular line. It could be this line here as long as it's formed perpendicular with our given line here, or it could also pass through here, pass through there. So just set this specifically as a normal line passing through point P. Let's just simply pick point P because if that line or perpendicular line passes to point P, then they share the same coordinates as the given line. So let's just use here the point P, not this one here. Okay, so this is still 1 and 2, but they have the same coordinate, but I'm talking about P on the normal line. So basically, you will have this form here. So your A is -4, -4 given here, times your X, now this is your X, that's your Y, times 1, plus you have here, your B is a 3, times 2, plus C equal to 0. In solving for C, you have -4 plus 6 plus C is equal to 0, positive 2 plus C is equal to 0. Then you will have here c is equal to negative 2. This is our c intended for our form. Hence, ax plus by plus c equal to 0, where x and y are now arbitrary constants. So you will have here a is negative 4x plus, not arbitrary constant, arbitrary variables. So you have b is a 3 times your y. Then you have your plus negative c is equal to 0, or negative 4x plus 3y minus 2 is equal to 0. If you would like our leading coefficients to be positive, so multiply all terms by negative 1, you will have 4x minus 3y plus 2 is equal to 0. This is now the equation of the normal line. Okay? The normal line, meaning the perpendicular line, specifically for this point. And you would see that it's actually correct just by examining the a and b coefficients, because we know that in our high school years there is a relationship between the a, b coefficients, or the slope identified as a and b, right? Because the slope here, the slope for this form is actually identified as negative a over b. That's a shortcut. So you have, for this form, so you have a is negative 3, your b is 4, right? And for now, for your m sub 2, for this, so you have here negative 4 over negative 3 is actually 4/3. And the relationship for them to be perpendicular, and we know that to be true, is that it's actually a negative reciprocal. So negative for this, and then reciprocate, so we'll get the same equation. Slope. So that's actually correct. And since this passes to the same point P, 1 and 2, this is now the correct form of the equation of normal line in terms of ax plus by plus c is equal to 0. So again, before going to this, we need to understand that in the previous video of writing the equation of a line, from a vector, we go to normal vector and use that for a and b coefficients. But for equation of a normal line, we simply use this vector, or if this is not given, from normal vector into that. So we're just because again, normal line and the line perpendicular to that actually have the same relationships, that their vectors are orthogonal. Okay, so that's actually how it is done. We'll have one more example to this. The second example in the previous video talking about the equation of a line in the form ax plus b plus c is equal to 0 using different points. And we're also going to look at their relationships as well. Thank you very much for watching.